I hit record. Okay, I can simplify and solve multi-step equations. Like I said, we're going to do 2 content objectives. We're going to go through this vocabulary. What is the difference between an algebraic expression and an algebraic equation? What does the equation have? An equal sign. Algebraic expression does not. So, here's what we're looking at here. This is a vocabulary word I want you to become very, very familiar with. He made this way too hard. Am I short one or you got them all? Okay. All right. Constant is a word I want you to become familiar with. The word term, 4x and 3, those are terms. Okay? Constant is the term that has no variable. So in this case, the constant is 3. The other way to think about this, can 3 be anything else but 3? No. No. It can't be. It stays constant. Okay? Coefficient is the number that's next to your variable. I am pointing these out because they will always use these terms in state testing. You need to know what a coefficient is, and you need to know what a constant is. You need to know what a term is. Okay? All right. Here we go. We're going to first review what's called the distributive property. Okay? Bless you. You did the distributive property in 6th grade. This should be a review, so we are going to go relatively fast. Stop. Okay, bless you. All right, we're going to jump right down into the distributive property. The distributive property is when we drew our arrows. What operation does distributive property doing? Multiplication. Distribute means to multiply it, to distribute it to it. So you're going to multiply these. I see I'm writing and I see several people who are not. So I'm going to take the 3 times the x and I'm going to get 3x. I'm going to cover up the terms in front of 4. Is that 4 positive or negative? Negative. So positive 3 times negative 4 gives me negative 12. Okay. I'm going to distribute this one. 1/4 times y is going to give me 1/4 y. 1/4 times 32. Could I simply type in 0.25 times 32 in a calculator and get my answer? What is it? It's 8. I could also just divide by 4. Okay. Now, time out for a minute. We're going to distribute this, right? Is that 2 positive or negative? Negative. And that 6 is? Negative. Okay. So I'm going to take negative 2 times 5x, which is going to give me negative. Negative 2 times negative 6, which is going to give me? So why did I switch that from a minus to a plus? Yep, and I'm telling you that 12 is positive. Okay. Top of the next page. I would like you to do those 2 problems. Don't forget that negative times a negative. It's going to matter. Distributive property, is that something new to you? No, it should not be. It is a standard in 6th grade. Okay. I'm going to distribute the 9 to both things on the inside. So what is 9 times x? 9 times 4?
36.
Okay. I am distributed. Negative 2 times 4? Negative 2 times negative 7?
14.
Positive 14. So do we understand why we switched that to a plus? Okay. Okay. Here we go. Now, I would write that down. Combining like terms, you will always add to do that. You can only combine like terms if they're on the same side of the equal sign. Negative 8x, and 5x are like terms. Why? Like terms because they have the same variable. Can that y go with them?
No.
Because it's not the same variable. Why are these two like terms? What do we call those? Thank you. These are both constants, therefore they are like terms. So what we're going to do with this is if I do want to combine my negative 8 and my 5x, what would that give me all together?
Negative 3x.
So negative 3x. Can I combine that 6y with anything?
No.
So bring it down. 4 and negative 2. What would 4 and negative 2 give you? Just 2. So this right here is my simplified version of that. Does that make sense? That's why we're going to combine like terms. Make it shorter, make it smaller. Because when we start to go balance these, we're not going to want them big and drawn out like that. That's more work. Okay. Ladies and gentlemen, I'm going to say this one more time, and I haven't had to say it to a single math class. I know that you guys are used to, like, really knowing what we're doing, right? But if I write it down, you write it down. Okay? There's a method to my madness. I promise you I'm doing it for a reason. Okay? Okay. Here we go. We're going to simplify. So right now, am I at an expression or am I at an equation? Expression, and I know that how? Thank you. Do you see something? So we want to get this as small as we can get it. Do you see something that I should start doing? Okay. Chris, what were you going to say? What's that property called? Say it. Distributed property. Distribute. So We see that right off the bat. We should be able to see that. So we're going to distribute first. Is that a positive or negative 4? So negative 4 times positive 6 gives me. Okay. Now I'm going to distribute that negative 4 to that positive 2. So look, what did I switch there? I switched the plus sign to a minus because why? What's that telling me about that 8?
It's negative.
That's negative. Now I'm going to go ahead and bring down everything I didn't use. Gee, I want to get this small. Is this small yet?
No.
What do you want me to do?
Combine like term.
All right. I see this guy, and I see this guy. Do you agree with me? Okay. Negative 24. And we're always doing what operation when we combine like terms? Add. Okay, so negative 24 and negative 3. Okay. What other like terms do you see?
Minus 27 next minus
Negative 8 and positive 7. So if I combine those, what do I get? Is this a lot smaller than that? Yes. Okay. There's a reason we're doing this. We're getting there, I promise, but we got to practice this first. So what I want you to do is there's one at the top of the next page. I'm going to leave this one up here. So that way you don't have to flip back and forth if you don't want to. I want you to distribute it and get it going. Try it. Okay? I'm leaving my example up there that we just did, so you don't have to keep flipping back and forth. Give this a try. Do you suppose if I keep hammering home, gee, is this an expression or an equation that we're probably going to switch? Do you have it anymore? Okay. No, because then I have 1. Yeah, and if you write y, you'd have 1. If you write just y, that means I have 1 more. Yes, guys. Huh? I know. You don't know that at the time, though.
It cancels out the y's.
Why?
The y's.
I'll ask you what. What is it? 2 times
Okay.
you got it.
All right. Algebra, back up here, please. Your algebra. Algebra, back up here, please. Algebra, you'll owe me lunch. Back up here, please. No reason I have to ask 3 times. Okay. Yes, I know it was right here. Very well aware. Okay? Now, what was the main confusing part for you? Yes?
When we have a positive and a negative of the exact same thing.
Exactly. And then you're probably going, okay, do I just write y? What do I do? It cancels these other, because if I still write y, that means I have 1, right? Do I have a y? No. Okay, so let's go ahead and distribute this, and we're going to show where we're talking about right now. So I have 2 times 3y, which is 6y. 2 times negative 5, which is negative 10. Bring down what I didn't use. So right here was what we were talking about. You went to combine this y with this y. Well, 6 plus negative 6 gives you And it wouldn't make much sense to write 0 y, right? Because how many y's do I really have? So do I even need that there? No. So I'm going to combine the like term, negative 10 and 8, which gives me negative 2. Okay. Now, like I said, I've been asking the same question every time. Do I have an expression or do I have an equation? Equation now. The whole purpose of leading up to this was you know how to do distributive property and you know how to combine like terms because now we're going to use them in equations. Okay, here we go. I'm going to write it over here just because I want to have more room. Okay. What do you notice I have first? So I need to do what? What's that word that I need to do though? Distributive property. Okay. What is 5 times 3? 5 times negative 6. Okay. Anything new we've done so far? No. This is not new learning. Do I have this side as small as I can get it yet? What do you want me to do? Okay, so how many like terms, how many constants do I really have? No, I have negative 30 here and I have negative 32, or I have negative 2 here, so how much do I have altogether? Negative 32. Algebra. We need to do a better job of focusing and getting rid of the sidebar conversations. Understood? Okay. Now, are we right down to a two-step equation we already know how to solve? Yeah, because your checkup that you took on Friday says you do. What should I do? Go ahead.
Wait, are we canceling it out?
Yep,
now?
we're balancing it.
Okay, that is plus 32.
Very good. What happens to inverse operations? I got to do to the other side. What happens to these guys right here? Cancels. So I have 15x equals 60. What would be the next thing you would like me to do? Whatever I do to one side, I have to do to the other. So what does x equal? 4, 5. Which one is it, guys? Okay. All right. All right. Now, here's the unfortunate thing. When you check, you have to go back to the original problem. You don't get to start like right here. So we're going to check it. This is where we use this.
Parentheses. Exponent.
No, I went to put a parenthesis and I didn't mean to. So pretend that's not there. Okay. PEMDAS says I do what first? Inside those parentheses, what should I do? All right. Do I still have parentheses? Yeah. What should I do? Okay, what is 12 minus 6? PEMDAS says I should do what? Multiplication. So what is it now? And then 30 minus 2 is? what I'm doing is I am proving that this side of the teeter-totter weighs the exact same amount as that side of the teeter-totter. Yes, sir. I go fast. Okay. If you will notice at the top of the back of this page, I did the harder one. I'm being nice. I want you guys to try this one. Would you like me to leave my copy up? Yes? Okay. You guys are trying the one at the top of the next page. Quick. Okay. I'm going to go ahead and flip over and do this one. What'd you notice you had to do first? What's that word? Distribute. I'm pretty sure it wasn't that one. I don't know that one. I can't either sometimes. All right, so what's 2 times 5? 10x. 2 times 3. All right. What is it that you want me to do? From both sides, though. 10x equals 20. X equals? All right, so we check. We always go back to the original. Or I need to remember I'm in algebra. I'll put those in parentheses. Okay, this is PEMDAS. Parentheses first. So inside that parenthesis, what do you want me to do? Okay, so 2, 10 plus 13, or 13, 3. All right. Now, what do you want me to do? So I get 13. And final thing? And I get that they match. Okay, I want pencils down, mouths off. We're not done. We're so not done. But pencils down and mouths off. Because if you don't pay attention to this part, it is going to be confusing to you. Do you notice by this problem, I have variables on both sides and constants on both sides? Do you see that? Okay. There's actually 4 ways to start solving this problem, all of which are right. I'm going to tell you what my algebra teacher told me. There were 2 things I remember from her. The quadratic formula is sung to Pop Goes the Weasel, and you'll never forget it. And that if you have a negative variable, you always start with it. So do I have a negative variable?
Yes.
Yes. So if I were to start with the negative variable, I want to show you something. Now, previously, anytime we saw that, what were we doing to get rid of it? Dividing. Because that separated the 2 from the x. Agree?
Yeah.
I don't want to separate the 2 from the x. What I want variables on one side and I want constants on one side. So I want this guy over here. I don't want to separate the 2 and the x. How do you think I could do that? It's a negative 2x right now. Positive. So I could do this. Opposites cancel. I'd have 9 equals 6x minus 15. Is that a problem you know how to solve? Yes. Okay. Now hold on. Now, let's say, you're brain dead that day and you don't remember to get rid of the negative one first. And you go to the positive one. That's okay. How would I get rid of the positive one?
You gotta make negative.
Yep. Opposites cancel. Now, here's the only reason that I think this one's easier than this one. When I start messing with negatives, I know myself, and I am much more likely to make a mistake. Anyone else in the same boat as me? Yeah, I know myself, and if I can stay away from a negative, I will. I would choose to do that. That by getting rid of the negative one, that's what helps with that. If you don't have a negative one, you get rid of the smallest one. Okay, so there's 2 ways to start, right? I told you how many ways were there? 4. Okay. Now, on those first 2 examples, we got rid of the what's first. The variables. So, what do you suppose I could get rid of first this time around? The constants. Okay, how would I get rid of a minus 15? Now, here's the only reason I personally don't do it this way. One is because I was never trained to do it this way. I don't like it. My brain naturally goes somewhere else. Now, have we ever had a problem where we have the variable on both sides and only one constant? This is not our normal, is it? Is that our normal? Is that our normal? Yes. This is not our normal. That's why I get rid of the variables first. So over here, I'd have negative 2x equals 4x minus 24. That's a lot of negatives, and I've got 2 variables yet. So that's why I would say go with our normal. Get rid of those variables first. It's going to make more sense. Do you see that? Yeah. Are any of these ways correct?
Yes.
Yes. So if you do it this way, are you going to be wrong?
No.
Did you make your life harder?
Yes.
Yes. Okay. So that's what this is proving right here, guys. All right. So now pick up those pencils. We're going to write this off to the side so we have room to work. What do you want to get rid of first? Negative what?
Variable.
Negative variable. I'm going to add to get rid of it because I'm just moving it over here. I'm not actually getting rid of the x. I'm just moving it to the other side. So I have 9 equals 6x minus 15. Yes, sir. Are you sure you want to miss this? All right. Okay. What am I going to get rid of? Plus 15. Plus 15. So now I have 24 equals 6x. What is it that you'd like me to do?
Divide by 6.
Divide by 6. X equals 4. By doing it that way, did I really work with any negatives? No. Now, here's the other main difference. When you go to check, you have an x here, and you have an x here. So how many times are you putting 4 in? Twice. So I have negative 2 times 4 plus 9 equals 4 times 4 minus 15. Chris, now would be a great time. That's the only thing I didn't want you to miss. So now we're going to just solve it. And when we check, we're always using PEMDAS. Please excuse my dear Aunt Sally. I don't have parentheses. I don't have exponents, but I do have multiplication. So I have negative 8 plus 9. And I will allow you to solve both sides. Like, do the multiplication on this side too. So that would be 16 minus 15, right?
Yes.
Negative 8. Add back 9 gives me 16 minus 15? 1. This is why I have been so adamant that you show your checks and solve every step, because I knew this was coming up. A lot of you on your homework got lazy and just wrote this out, and wrote answers, and that was it. No, every step. Okay, guess what? Your turn. You guys have that one at the top that you can watch. Do you have a negative variable? So what did I say? The smallest. So you do the 2x. I do the smallest variable. Punch these. Flips this way, watch. So you're going to put paper in front. See that? And if you just put them all together, one person at your table can all punch them all right away. Would you be opposed if I went over this one, or are you still working? Okay. You're not even doing the problems as I'm doing. It's not acceptable. Okay. It appeared most of you were done or you're at a point where you are frustrated. All right, here we go. Do I have a negative variable? No. So what did I say we should do next? Smallest. Okay. Would you agree with me that 2x is the smallest?
Yes.
It's a positive 2x. What is it that you would like me to do?
Negative 2x.
All right. Opposites cancel. Whatever I do to one side. Okay. So I have 5x plus 42 equals 12. Do you agree? Okay. What is it that you would like me to do now? Yes.
U minus 42.
Minus 42. Opposites cancel. Minus 42. 5x equals negative 30. Am I done yet?
No.
What is it that you want me to do? X equals? Okay. So now what am I going to do with this? So 7 times negative 6 plus 42 equals 2 times negative 6 plus 12. This is PEMDAS, right? Do I have parentheses? No, because these parentheses are just showing we're multiplying. So I'm going to multiply first. 7 times negative 6. What do I get? Plus 42. Over here, 2 times negative 6. Plus 12. What am I going to get, guys?
0.
My teeter-totter matches. Oh, that kind of makes a sad face.
Oh, it does.
Okay, what you're going to do right now is you're going to switch that to that sheet I just gave you. Nolan, who am I missing next to you? Who? Alex, thank you. Okay, now, this is the point I have to make it to, and I have 7 minutes. What I want to do is we're going to work through, and we're going to say negative 5 is my solution for this. Okay? So I'm going to put in 4 times negative 5 minus 8 plus 2 times negative 5 equals 4 times negative 5 minus 10. Yes, I understand there's not a lot of room. I get that. If you're a big writer and you need to get out a separate sheet of paper, that is fine. But what we're going to do is we're going to solve this.
Solve it.
It's like we have the answer of negative 5 and we're doing the check to make sure we're right. That's the point we're at. Here's my solution, and I'm checking to see if I'm right. What is 4 times negative 5?
Negative 20.
And then I have 2 times negative 5, which gives me negative 10, right? And on this side, I have negative 20 minus 10. Does everyone see where I got that? Okay. Negative 20, take away 8. If I'm at negative 20, I take away 8 more. Negative 28. Take away 10 more. Negative 38. And on this side, I have negative 20, take away 10. Is negative 30. Do you agree? Turn it around the other way, gentlemen. There you go. Okay. Was negative 5 a solution? No, it didn't work. Negative 38 does not equal negative 30. It doesn't work. Like I said, they do not give you a lot of room, so if you need to write off to the side or get a separate sheet of paper, that's fine. My goal, and you can put your notebook away when this is done, is I want these next 3 done. Okay? You're going to put -1 in now, just like we did. I want those last 3 done.